Okay. Good morning, everyone. In our few last classes, we had covered the portions of the LL1 parsing, uh, which comes under the top-down parsing technique, correct? Now, today onwards, we will be focusing on the bottom-up parsing. If we see the category, let us make a complete review of what we covered still so far. Actually, the parsing technique was categorized into two separate zones. One was top-down, and another is bottom-up. Now, under the top-down, we mainly focused on LL1. Also, we focused on recursive descent parsing. Correct. So, under the LL1, what we did, when a grammar was given to us, first for that grammar, some production rules were given. For example, A to BC, B to D, C to M, or epsilon, like that. For that grammar, when they have asked us to check whether the grammar is LL1 or not, that means whether the grammar is fit for top-down parsing or not, then corresponding to that grammar, we have to generate a predictive parsing table. So in that table, what we did, we had to create the columns. Here, in the column wise, we write the variable names, and the row wise, we start writing the D and M. These two terminals are there. That's why we have written two. So first, a rudimentary table needs to be prepared. Now for the grammar that is being given to you, if the grammar has left recursion, or it is not left factored, then both the operation to be performed over the grammar and the new grammar to be generated. New grammar means the equivalent grammar. Correct. The grammar that I have taken over here, that is fine. No, there is no requirement of left factoring or no requirement of left recursion remove. Now, once this grammar is being obtained, you have to find out the first for all non-terminals. Terminals. Non-terminal means you have to find out the first of A, you have to find out first of B, you have to find out first of C. So when finding this A, B, C, you need to fill up the respective cell. For example, these cells are filled up. I have not checked. I am marking it here. So this is the initial operation that you are performing by finding the first function. But last time we said add C is generating epsilon, so you have to calculate the follow of C as well. To find out follow of C, some rules were there. Basically three rules were there by which we generate the follow of C. And a new column is being added here that is called dollar. By finding the follow of C, the required cell are being filled up. Let these two cells are being filled up. I don't know which cells to be filled up. Just for an example, arbitrarily I am filling the cell. And if we find no double entries in the cell, then it is fine. The grammar is LL1, which in turn means the grammar is fine for top-down parsing. Again, which we try to understand, that mean the grammar is error free. That means initially in a class, I hope you can remember that we had taken some codes. I asked you to check whether this was a syntactical error. The code has syntactical error or lexical error or semantical error. So that means the grammar that is being given here, if the grammar is LL1, that means the sentence or the code, the C code that you have already given to you, which is based on a grammar G, that is G, the code is error free. Error free, which error free? Syntactical error free. I hope you can make a connection over here. So why we need to check the grammar is LL1 or not? It is fit for top-down parsing, which in turn it is error-free in terms of syntactical error, because the code is processed by the LL1 grammar. Okay. Now, it up to that we discussed. Now today onwards we'll be focusing on this bottom-up parsing. This is more likely this LL1 parsing, but some new thing to be added, correct? So slowly we will be progressing. In today's class, mostly we will be focusing on the preliminaries on the bottom up parsing. Then we will be moving to the higher zone. Okay. So bottom up parsing, like top down parsing, had two categories: recursive descent and LL1. Mainly two categories. Bottom up parsing will be having two categories: operator grammar. You have to know this, and also operator precedence parsing also is there. Another parsing technique is called LR parsing. You have heard about LL, and now it is LR. The first L stands for left to right scan, and second R stands for RMD, rightmost derivation. Under LL, we seen left to right scan and leftmost derivation. Here it is rightmost derivation. Correct. And here also some token will be there. It may be LR0, it may be LR1. So depend on the how many look ahead token it is finding. So one question definitely will be in your mind that, sir, you never explain what is the use of this one. I said this was the look ahead token. So once this bottom up parsing is completed, then your idea will be clear whether we have to write LR0, whether we should write LR2, or whether we have to write LR1. Okay. Let's move to the main PDF. Okay. This is the main portions from where we will be starting. Now, uh, here, just I am drawing one more diagram. So I said two portions will be covering under the bottom up parsing. This is bottom up parsing, BUP. Okay. One is operator grammar. Okay. Another is LR parsing. LR parsing, correct? Now, LR parsing have three, sometimes it is said four categories, correct? You no need to remember here. Later we will be covering those portion. Just here you also can see one diagram also I have given here that will be requiring. That's why I have to write this different forms. First is LR0. This is SLR1. You can assume LR0 mean the uh, it is the uh, it has the lowest power, LR0. SLR1 means its power is high than LR0. Like you can assume LR0 means a state, like a district in a country. SLR1 means it is a state in a country. SLR1, then this is LALR. You can assume this is a country, LALR. And then CLR. You can assume this is entire whole world. LR0 means it is a district. SLR1, this is mean it is a state. LALR, it is mean country. CLR means state. So that means you can assume the states in term of state. If I representing it, so it will be LR0. Then SLR1, it will be SLR1. Then after that it will contain LALR. After that it will contain the CLR, right? So this is the architecture. Now some modifications in the diagram I have to make later. Now, as of now, you can assume this is the architecture. And LL1 parsing that you have still, so that actually what you have seen that the grammar perspective actually belong in this region. LL. Some portions are in this region, some portion in this region, some portion in this region, some portion are in this region. So if a grammar is LL1, someone is said that grammar G is LL1, then you cannot tell that the grammar definitely will be CLR or LLR. Because if it is to be CLR, then the grammar should lie in this region. But if the grammar lies in this region, then definitely it is not CLR. Correct. Now we will be covering those portions once again later. As of now, just try to understand that. Sorry, one mistake. One mistakes I have done over here. Ah, okay. I was telling that whether the grammar is L at 0 or not. The previous case that I had considered, that grammar G is given to you, the grammar is LL1, it is being said. Now, if someone tells if the grammar is LL1, then whether the grammar is L at 0 or not. In this time, you cannot tell that whether the grammar is L at 0 or not, because if the grammar lies here in this portion, so that means this outer region, the L at 0 region is up to this. So it is out of that region, so grammar cannot be L at 0. If someone asks the grammar can be SLR1 or not, certainly not. I cannot tell without checking. So also the grammar can belong to the same region. But if a grammar is LL1, then definitely the grammar is CLR, because CLR is the entire region, correct? So one thing you can remember, that if a grammar is given to you, then and it is being said that LL1, then you cannot say that the grammar would be LR0 or SLR1 or even LLR. But definitely the grammar will be CLR, because the highest region that it will be covering under LL1 is up to the boundary of CLR. Okay. Now, here you can see the same diagram I have shown here, that this is the LL1 region. This is LL1. This is LR, CLR, LALR, all the parts I have written out here. You can check all the parts I have written out here. And interestingly, you see that I say the grammar actually can be of two types. One is called ambiguous grammar, and another grammar is called unambiguous grammar. So I hope you can remember what is ambiguous grammar. If a grammar have more than one LMDs, LMD1, LMD2, simultaneously RMD1, RMD2, then the grammar is ambiguous. I hope you can remember. I explained in my class also and also in the previous videos. Unambiguous means exactly one LMD and exactly one's RMD. Two derivation tree based on leftmost derivation, based on rightmost derivation. Correct. So the spectrum of a grammar is categorized into two zones. One is called ambiguous grammar zone, another is called unambiguous grammar zone. So whatever the operations, the top-down parsing or bottom-up parsing, whatever the logic we are employing over here, you can check. All are based on unambiguous grammar. We cannot process the ambiguous grammar. That's why it has a separate region. But entire grammar, if I consider, then the entire grammar has this region. Okay, fine. The architecture or the design that I have given here, I hope you can understand the same thing I have said here. Okay. Now, uh, here also I have written that in bottom-up parsing, that two categories are there. One is called shift reduce parsing, another is called operator precedence parsing. Okay, in a way to know what is called operator precedence parsing, operator grammar we also has to know. Operator grammar, that is also important. And LR parsing, I said now L stands for left to right scan and R stands for RMD. So this LR parsing sometimes is known as shift reduce parsing. If you don't want to remember this term shift reduce, you may forget. But certainly we will prove that this LR actually, whatever the operation is doing, it is shifting and reducing. It is shifting one by one unit and it is reducing the size of the production. That's why its name is shift reduce parsing. Okay. Okay, so that what still we have covered, just we have came to know what are the different categories of bottom up parsers, and what are the uh, architecture we have given the Venn diagram of the bottom up parsing. Different terminologies we have seen, and we have seen if a grammar is LL1, that means the grammar will be CLR. What is CLR? What is SLR? What is LR0? What is LLR? LALR? We will be looking through all the different segments one by one, and also slowly. Now, before entering the main zone, that means different grammars, we have to introduce some more terms over here. First is called handle. I hope in my class also I pronunciated this terms, that what is called handle. Uh, this is handle means, let this is the grammar is given to you. This grammar has this production. The second is this production and this production, correct? And now someone has asked you to give this uh, string from that production. This is not very tough to generate this string, because you have to expand the production, correct? First, so our my objective is to generate this string from this production. How to generate? So how I can generate? Let here I am writing S is generating small a capital A B C, small a capital B and C, right? My intention is to generate A, B, B, D. Here I am writing. My intention is to generate A, B, B, C, D, and E. So A is already obtained over here. B, A, B, and C to be factored. What I can follow? What I can follow? Here, B can be replaced by D. So A, capital A, this B, because the rightmost derivation I have to take, D and C. It is LR. This is RMD, rightmost derivation I have to take. Correct. I cannot break this A first, because this is A is a variable, B is another variable. If I break the A variable, it will come under the LMD, leftmost variable I am breaking. But I should break the rightmost variable, that is B. So small a, capital A, D and C, this is I have obtained so far. Okay, this is not A, B, D, E. Okay, this is not C, this is E. This is E. Okay, so I have the D and E term, also D and E term I have obtained, right? Also A I have obtained, right? Now I have to break A so that BBC I can obtain. BBC how I can obtain? A can be broken as A can be broken as capital A B C. Okay, so I am breaking A. This is small a. Again I am writing. This is capital A, small b and C. Then D and E is being left. Okay. Now already this D and E obtain. BC also this is has BC. So I can obtain BC over here, B and C. Only B is being left, right? So I have to take an eraser over here. Now finally small a, capital A, B, C, and finally this A also can be replaced by B, right? So small b, B, C, D, and E. But every time I am performing the RMD's rightmost derivations, and finally I obtain the desired string. Correct. This is I have obtained still so far. Now, the way I have performed here, if I change the way that I am performing, so here I approach from top to bottom, correct? Top down manner. But if I moving up from bottom to up, if I'm moving bottom up, then it will be a bottom up parsing. So that means if I start from S over here, just see, and I hope you can see one examples I had given in that previously, that how it can be formed. Just you can also quickly revisit that portion also. So if I am moving from S to this zone, S to this zone, then definitely it will be a bottom up parsing. So here how I moved from S to here, actually from here to here, correct? If I am performing the reverse operation over the same production, reverse operation means, okay, actually I should not give this arrow symbol over here. Here you see that this was the operation here I have performed. If I flip the arrow over here, so that means if I flip the arrow, so A, B, B, C, D will come in the first. Then after that, it will come A, small capital A, B, C, D, and E. After that, it will come small a, capital A, D, and E. After that, it will come small a, capital A, B, and E. After that, it will come S. So here I have performed the top down, but if I flip it, that means it will be a bottom up. and I have written in this way. So this the parsing that I have obtained over here, this will be called a bottom up parsing. Correct? In different architecture, let me check whether the document is within me or not. Let me check. Okay, just wait a minute. Okay, just wait a minute. Okay, yes, this example. I hope you can remember this example. Uh, in this example, let me take the tool marker. Okay, pencil. Okay, now you can see that in this example that I have shown here last time, you should see the video also, that how I form the tree. Correct, the same example I had taken. I had approached in bottom up manner, right? What I did, I had taken this string first. After taking that string, I broke the string in every segment that I can. So first A, B, B, C, D, E, that string I had taken. Let me show it here, how I did it. Let me show here. Okay. Here I'm writing. The string was A, B, B, C, D, and D. Correct? Now I have to approach in bottom-up manner, right? And the production rules, what were the production rules? Let me write the same production rule over here. S to small a, capital A, B, and E, capital A to capital A, B, and C, or B, and capital B to D. These are the productions that we had initially, right? Now I have to approach in bottom up, right? First, what I am doing, I am breaking this B. Okay, let me change the color. I am breaking this B into A, correct? Because A can generate B over here. Perfect. So I am approaching in bottom up. I am approaching from bottom up. Okay. Now, what values I have? This small a, capital A, B, C, D, and E. Correct. This value I am having now. Now, what more I can do? A can generate capital A, B, and C. So if I take this capital A, this B, and this C, can I cluster them? Yes, I can cluster. I can make a cluster of it, and it can generate capital A, right? This capital A. Now, what values I am having now? Let me change the color. Now, I have the value small a, capital A, the green color part I am showing, D and E, right? Now, how I can do, what far I can do? I can replace D with B because B can be replaced by D. So this D I am replacing with B, right? Now, again, I am changing the color. I have to take a different color. Let me check the blue. So now I have the value A, I have the value B, and I have the value of E. These three values I have. And also this A also is there. Now I forgot that part because these four nodes are there in between nodes. All the leaf nodes are being connected. And now small a, capital B, and E, this is the production I can obtain from S. So here, 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 and here also I can connect from S. S is the root node. Right. So this tree that I have formulated, you check, I approach from the string and reach to S. So approach from the string A, B, B, C, D, and E, and reach to the string. So the way I have approached it, that's why the approaching pattern is known as bottom-up approaching. Subsequently, the rules that I will be applying later, that will be known as bottom-up parser. Okay. Don't save. I have to cancel it. Okay, I am closing this portion. Okay, now I am moving to the main content that which over which I was focusing. So I have explained what is called bottom up parsing. Now what is called handle? You see that while expanding the, let this is the grammar that is given, and this grammar is well known grammar before you already, several examples we did over here. Now when I am breaking the grammar to generate certain string, let someone has asked us to generate this string id to id plus id, right? Now let me take the this part so that it will be easier for you to follow. Okay, now have to make it small. Okay, fine, now it is fine. Okay, I'm taking a red pen over here. Okay, now you see for this grammar, someone has asked us to generate id plus id star id. This is the desired string I have to produce, not s I should write. This is the w, small w. It is the representation of w. This is a string. Now if I start breaking this e, start from e is generating first e to e plus e. This is the productions. Forget about top down or bottom up, just I am showing the way I am going through. Previously I have explained that how the bottom up parsing works and what exactly the terms bottom up parsing came into picture, as the approaching style was from leaf node to root node. Now e to e plus c, this is the production, this is the left variable and this is the right variable. So you know that in bottom up parsing I cannot, it is lr. Every time I have to factor the right variable, not the left variable. Under the LL, every time I have to factor the left variable. So I cannot factor the left variable this E. I need to left factor this E. Correct. So now if I factor it, E2, E, this E remains same. And this E, I am replacing with E star E. Correct. Once it is being done, again the right variable is this one. I am changing E to E with another E can generate ID, you can check. So star ID. Then again this E plus this E I am breaking now. This is ID star ID. Again then this E I am breaking finally. This is ID plus ID star ID. Right. Now while breaking this into small segment, okay, let me change the color. Okay. Now whatever the breaking point you have used. So first you have used this breaking point. See the underline part that I am marking. Next, you use this breaking point. Next, you use this breaking point. After that, you use this breaking point. And finally, use this breaking point. So whatever the underlines I have made out here, those are known as handles. Correct. And the way I did it, that is known as pruning of handle. Correct. I hope the idea is clear. We have to perform the rightmost derivation or right factoring, and the portions where I am performing the factoring, that is known as handles. Several exams, how they ask the questions, they actually give you the grammar that is given to you here, and production rules will be given, a string. So grammar, production rule will be given, a string will be given. They will ask you to generate the handles. So you should write what are the handles. This is the handle, this is the handle, this is, and this is. Okay, fine. Okay, now the second portion. Okay, this is also very interesting part, that operator grammar. Let me erase some of the portion over here. Now you see in this, from this document, that this is a term that I have used, not I have used, this is well-known term, this is operator grammar. So a grammar G can be said an operator. A grammar, you know that content production rules now. So the all grammars based on the production rules. Now in the production rules, let I have a production rule A2BC and B2 D and capital C2 small I, right? This is the production rule that I am having. Now, when a grammar G can be called a operator grammar, the grammar can be called an operator grammar if the grammar does not contain any epsilon move. This is the first condition. And the second condition is it does not derive two adjacent non-terminals. What does it mean? It means that here in the production, nowhere the epsilon move is there. If I write this epsilon move over here, that is a problem. And also under the second point, does not derive any two adjacent non-terminal, but here two adjacent non-terminals are there, B and C. Both the criteria to be satisfied. That means if I change the grammar in this way, let A is generating small b, capital M, B not capital B, M, let this is M is generating small m, then the grammar is operator grammar. Fine, no problem with that, with this grammar. But if I change the grammar in this portion, capital B, capital M, capital B is generating small b, capital B is capital M generating small m, then definitely the grammar will not be an operator grammar because two variables are adjacent. Okay. If I change the grammar in this, A to small b, capital M to small m, up to that it was fine. But if I add epsilon over here, then definitely the grammar will not be an operator grammar because there is an epsilon move. Correct? I hope the idea is clear. So which is the operator grammar? This one. This one is not, due to the presence of two non-terminals back to back. Here also you can find the grammar is not operator grammar due to the presence of epsilon. Okay. Now precedence of operator, operator grammar. The precedence of operator part already I have explained previously. Correct? By designing a tree, you can remember that this is let this is an operator I had. For example, let this is a plus symbol, this is a minus symbol. Here it was 2, it was 3, it was 5. So under the operator precedence part, you check that minus had higher precedence than plus. If I had it, this is this specific tree for a grammar, for a production rule, right? So to check that what is the precedence of minus and plus, we have to approach from bottom up. You can remember, because first you have to perform this minus operation, then you have to perform the plus operation. So that's why the operator precedence part that actually we perform earlier, that comes under the bottom up parsing, because we have to approach from bottom up. Again, I am repeating. And bottom up parsing means the tree that is being formed over here is based on certain grammar, and the grammar is based on certain production rule. That means the grammar and the associated production rule is fit for to process under the bottom up parsing if I can generate a parse tree and can traverse the parse tree from bottom up manner. Okay, that's all about the operator precedence. You should quickly revisit the portion, the operator precedence part you have forgotten. Uh, Otherwise, we can move to the second journal. Okay. Uh, Now, I hope that I should not start this portion today, because once I start this portion, I need to move fast. So not move fast, actually, I need to approach one by one. So up to today, whatever I covered, just make a quick review on it. Tomorrow, I will be uploading the second video, and then I will be explaining all the things one by one.